Bismillah, alhamdulillah, wassalatu wassalam ala rasulillah. Let us solve some more exercises about power series. So we have this power series, the center is 0, and to find the interval of convergence and the radius of convergence, we need to use the ratio or the root test. Here, the ratio test is applicable, so let us use the ratio test. -1, if you replace n by n plus 1, you will have n plus 1 minus 1, so I'll have n. And x to the power n is in the numerator, so I'm going to write it here and write it x to the power n plus 1, multiplied by the reciprocal of an. So I have n times 5 to the power n up, and -1 to the power n minus 1 times x to the power n. This will be cancelled with this, and I'll have -1 here or there, it doesn't matter, okay? Because this is n minus 1, and -1 to the power n minus 1 times -1. Okay, so what would we get? Absolute value of -1 would be +1. I have x, so absolute value of x. I have n and n plus 1 and 5 in the denominator, okay? N over n plus 1. N is a positive number, starts from 1. The limit when n goes to infinity of this would be 1. So this will go to absolute value of x over 5. So by ratio test, series is absolutely convergent if absolute value of x over 5 is less than 1. This means if absolute value of x is less than 5. This means that the radius of convergence is 5 and x is between -5 and 5. So this is the interval of convergence, but we need to discuss the endpoints using other tests because the ratio test fails at the endpoints. The limit would be 1. If x is -5, I'll have -5 to the power n. Okay, if I write it, I have power n and power n. So -5 over 5 would be -1 to the power n. And if I add the powers, I will have two n minus 1. And 2n minus 1, if you put in 1, you get 1. If you put in 2, you get 3. If you get in 3, you get 5. So you will always get an odd power. So this is an odd number, 2n minus 1. And when you raise -1 to an odd number, it will remain -1. So in fact, this is equal to -1 over n. Okay. If you replace n by 1, 2, 3, 4, whatever, always a negative number. Now this series you can say it's a multiple of the divergent harmonic series. So it is divergent. While if x is 5, notice the difference. That this point is really very important here. Because if you deal with -1 to the power 2n minus 1 as alternating, then this series is convergent. But if it is not alternating, if it's always negative, then it is divergent. So you have to differentiate. That's very important to concentrate here. Is it alternating or not alternating? If x is 5, I'll have 5 to the power n, and it will go with 5 to the power n. So the series would be -1 to the power n minus 1 over n. Now notice if you replace n by 1, you get -1 to the power 0, and that's positive. If you put in 2, you get -1 to the power 1, and that's negative. If you put in 3, you get positive, and so this is alternating. But when you multiply, when you have 2n, it is not alternating. So because this is alternating series, so it is convergent by alternating series test, because limit of 1 over n when n goes to infinity is 0, and 1 over n plus 1 is less than 1 over n, so it's decreasing. So the interval of convergence would be at -5, the series is divergent, but at 5, the series is convergent. So this would be the interval of convergence. Again, let us use immediately the ratio test. You just replace n by n plus 1 as usual, and you multiply by the conjugate of an, sorry, by the reciprocal of an. And then you search for cancellations. Okay. Now we will have absolute value of x over 2. Okay. And I have the following. I have n plus 1 over n. And I have n squared plus 1 over this. If you expand this, you will have n squared plus 2n plus 1 plus 1 plus 2. So if you, in fact, if you take the limit now when n goes to infinity, the limit of this is 1, the limit of this is 1. So it will go to absolute value of x over 2. And by ratio test, the series is absolutely convergent if absolute value of x over 2 is less than 1. This means that the radius of convergence is 2, and x is between -2 and 2, and we need to consider the endpoints. So in this case, I will have, notice, -2 to the power n. And here I have 2 to the power n. So when I divide -2 by 2, I get -1 to the power n. So I'll have -1 to the power n times n over n square plus 1. 2 to the power n will be cancelled with 2 to the power n. Now look to this series. This is an alternating series. So let us find the limit. Bn in this case is n over n square plus 1. And the limit of Bn when n goes to infinity would be the limit of 1 over n when you take the highest power from the denominator, and this is 0. And I need to check where the function is decreasing. So I'll find the derivative. Using the quotient rule, derivative of the numerator is 1. Derivative of the denominator 2x times the numerator. So I'll have 1 minus x squared. So it's clear that for x greater than 1, okay, can say greater than or equal to 1, it doesn't really matter, yeah. F prime of x, if x is 1, it is 0. If x is 2 or 1 point something, it's negative. So f is decreasing for x greater than or equal to 1. This means Bn is decreasing for n greater than or equal to 1. This means by alternating series test, series converges. So this series is convergent by alternating series test. If I replace x by 2, then 2 to the power n will be cancelled with 2 to the power n. And I'll have summation n over n square plus 1. And we can compare this series by Bn, which is 1 over n. And we see that n over n square plus 1 is less than n. Yeah, it is less than 1 over n. So this doesn't help. The direct comparison test doesn't help because this is less than this, not greater. And 1 over n is the divergent harmonic series. So I will use the limit comparison test. So I'll find the limit when n goes to infinity of an divided by bn or multiplied by the reciprocal of n. N square over n square, the limit is 1. It's greater than 0. So by limit comparison test, summation n over n square plus 1 is divergent. So the interval of convergence would be from -2 to 2, but at -2 it is convergent, while at 2 it is divergent. So this is the interval of convergence for this power series. I have factorial, so I'll use the ratio test. An plus 1 multiplied by the reciprocal of an. This is 2n plus 2. So when I cancel this with this, I'll have x to the power 2 remaining. And this is n plus 1 times n factorial. So I will have n plus 1. So I have x square, and now no need for the absolute value because I have x square and it's always positive. And when I replace n by 0 by infinity, x square over infinity is 0, and 0 is less than 1. So by ratio test, series is absolutely convergent for all the values of x. So the interval of convergence is from negative infinity to infinity, and the radius of convergence is infinity. Now the center is 2. The center is not 0 here. We do the same. An plus 1 ratio test. The reciprocal of an cancel, and we will have absolute value of x minus 2, and we have n squared plus 1 over, if you expand this, n squared plus 2n plus 2. And the limit of this when n goes to infinity is 1. So the limit will be absolute value of x minus 2. So by the ratio test, series is absolutely convergent when absolute value of x minus 2 is less than 1. This means that the radius of convergence is 1. And x minus 2 is between negative 1 and 1. To solve for x, I add 2 to all sides. So x is between 1 and 3. And now I discuss the endpoints. If I replace x by 1, I will get 1 minus 2. That's negative 1 to the power n over n squared plus 1. And this is an alternating series. And it's clear that it is convergent by alternating series test, because limit 1 over n squared plus 1 when n goes to infinity is 0. And 1 over n plus 1 square plus 1 is less than 1 over n square plus 1, because n plus 1 square plus 1 is greater than n square plus 1. So the series is convergent. While when x equals to 3, I have 3 minus 2, that's 1 to the power n, so it's 1. So I have 1 over n squared plus 1. And this is convergent by direct comparison test, because 1 over n squared plus 1 is less than 1 over n squared. And summation 1 over n squared is a convergent P series, because n is 2 and it's greater than 1. So it is convergent in both cases at both numbers. So the interval of convergence would be 1 and 3 closed. Question 22. You can check that everything is fine because the center here is, what is the center? We said it is 2 because x minus 2 to the power n, and you go to 3, the endpoints are 3 and 1. So what is the distance here? It is 1, and that's the radius of convergence. So the radius of convergence is 1. Use the ratio test. -1 to the power n plus 1, x minus 1 to the power n plus 1, 2 times n plus 1 minus 1, 2 to the power n plus 1. 2 times, this is 2 times n plus 1, okay? Multiplied by 2n minus 1 times 2 to the power n, -1 to the power n, x minus 1 to the power n. There is a -1 here. I have x minus 1 here. There is a 2 here. So this would be equal to absolute value of -1 is 1. I have absolute value of x minus 1 over 2. And I have 2n minus 1. And this would be 2n plus 2 minus 1. It would be 2n plus 1. The limit of this when n goes to infinity is 1. So the limit would be absolute value of x minus 1 over 2. By ratio test, series is absolutely convergent if absolute value of x minus 1 over 2 is less than 1, or absolute value of x minus 1 is less than 2. This means that the radius of convergence is 2, and x minus 1 is between -2 and 2. If I add 1, then x would be between -1 and 3. And let us consider the two cases, the endpoints. If I put x minus 1, if I replace x by minus 1, I'll have minus 2 to the power n. So there is -1 to the power n, -2 to the power n, and also here 2 to the power n. I can put all of them together because the same power. So -1 times -2 over 2 all to the power n times 1 over 2n minus 1. This is positive 2 over 2. This is 1 to the power n 1. So the series is 1 over 2 minus 1 from 1 to infinity. And I can compare this series with 1 over 2n. Now, summation 1 over 2n is a multiple of divergent harmonic series. So it is divergent. And 2n minus 1 is less than 2n. So 1 over 2n minus 1 is greater than 1 over 2n. So by direct comparison test, the series 1 over 2n minus 1 is also divergent. Let us consider the case when x is 3. I'll have 3 minus 1, 2 to the power n. It will be cancelled with 2 to the power n. And I will have negative 1 to the power n over 2n minus 1. And this series is convergent by alternating series test, because limit 1 over 2n minus 1 when n goes to infinity is 0. And 1 over 2 times n plus 1 minus 1, which will give you 2n plus 1, is less than this one because this is greater than this, which means it is decreasing. So the interval of convergence should be from negative 1 to 3. At negative 1 it is divergent, but at 3 it is convergent. So this is the interval of convergence. Let us use the ratio test. Some cancellations. So this would be equal to absolute value of x plus 2 over 2 and ln n over ln n plus 1. Well, the limit of ln n over n plus 1 when n goes to infinity will give you infinity over infinity. So I'm going to use L'Hopital's rule with the functions ln x over ln x plus 1. Now infinity over infinity, so I use L'Hopital's rule. Derivative of ln x is 1 over x, derivative is 1 over x plus 1. So if you simplify this, you get x plus 1 over x. And now the limit taking the highest power is 1. So this will go to absolute value of x plus 2 over 2. And then by ratio test, series is absolutely convergent if absolute value of x plus 2 over 2 is less than 1, or if absolute value of x plus 2 is less than 2. And this means that the radius of convergence is 2. And x plus 2 is between negative 2 and 2. Add negative 2 to all sides. Discuss the case at the two cases at the endpoints. When x is negative 4, I'll have negative 4 plus 2. So this is negative 2 to the power n. Now negative 2 over 2 all to the power n would be negative 1. This is a convergent series by alternating series test, because limit 1 over ln n when n goes to infinity is 0 because len infinity is 0 is infinity and 1 over infinity is 0, and 1 over len n plus 1 is less than 1 over len n because len n plus 1 is greater than len n because len is an increasing function. While when x is 0, I'll have 0 plus 2, so 2 to the power n will be cancelled with 2 to the power n, and I will have 1 over len n. The series 1 over len n. Can I compare this series with another series? What about 1 over n? What do you know about len n and n? I know that, of course, summation 1 over n is the divergent harmonic series. Len n is less than n for n greater than or equal to 2. Len 2 is less than 2. Len 3 is less than 3. You can check that by the calculator, and from the graph, len goes up but very slowly. So this is a fact. So 1 over len n would be greater than 1 over n. But then by direct comparison test, summation 1 over len n is divergent. And then the interval of convergence, at -4 it is convergent, but at 0 it is not. Ratio test. Let me stop here, not to make it too long, and solve the other exercises in another video.